Recorded rolling. It's Wednesday, November 5th. We're on lesson 5-2, solving polynomial equations algebraically. Okay, so still solving polynomials. And this lesson is kind of interesting because there's this bag of tricks for solving some interesting type polynomials. Okay? Actually, I have one pair of them here, which is sum of cubes and a difference of cubes. Okay, I'll take you guys through a couple of examples. Okay, so it turns out that a cubed plus b cubed, you can actually factor interestingly this way, a plus b, and then all that multiplied by a squared minus ab plus b squared. Okay? And if you have a cubed minus b cubed, which you can actually derive from just making b a negative number, so you could just have a negative two. What you end up getting is a minus b, and then a squared plus ab plus b squared. Okay, so careful about what's negative and what's positive. Okay? Right, so now that's not the only tricks they have, but that's some big ones. They have a whole list of tricks down here. There's a greatest common factor trick. I'll take you guys through an example that also involves that. There's now difference in squares. I think you guys have known probably for a long time, maybe before you ever set foot in this class. You guys did a squared minus b squared is a plus b minus b. You do that. We got some difference of two cubes, which is also up here. They just copy pasted it down here. It's the same thing. We got perfect square trinomials, general trinomials. We got grouping. So there's all these different tricks. Right, and then the main video recorded birthday go over all these different examples with you guys. Right. There's of course some word puzzles. We got some geometry shapes going on. Right, so those are fun. Okay. Yeah, I'll do a couple with you guys, and then just like yesterday, your Alex 515253 has been open, so you guys can work on it too. And so I'm going to cover number 1 and number 9 with you guys, and that'll be fairly comprehensive. Cover some good material here. So number 1, this is on page. Oh, wait, let's page 271. By the way, says 8c to the 3 minus 27 d to the 3. Right. So this one's fairly straightforward. I think you might be able to sort of envision your mind kind of where this is going. What I want you to do here, it says factor completely. Okay. And some of these might not be factorable, in which case you just write prime, so they can't be factored. So that's right. But a lot of these can be. And ooh, what to me this looks like is a difference of two cubes. Guys, what's the cube root of 8? What times what is equal to 8? How about 2? Yeah. So could 8 times c to the power 3 be the same thing as 2c all to the power 2? That's the same thing, isn't it? Right? And oh, kind of a similar story in this one. Guys, what times what is 27? Okay. Right, so 3 times 3, right? Yeah.
Oh, yeah.
Yeah. So how about 3d and then all that to the power? Hey, that's the difference of two cubes, which is exactly what I listed right here. So instead of a and b, now we just have a 2c and a 3d, but it takes the same place, doesn't it? It's like that. So I'm just going to follow this exactly. Actually, I'll just kind of fold this like this and just kind of follow that format. So that's the same thing as if I want to factor out. See, it says a minus b, so in my case that'd be 2c minus 3d. Okay, and that's all multiplied by, and that what is okay, got an a squared. So here, just to really spell it out, I got like a 2c being squared, right? Then plus ab, so that's a 2c times a 3d. Okay. Now this would all be positive. You might say, wait, what about this minus here? But don't worry, that actually is positive, so that's correct. Okay. And then plus, and then go see, 3d takes the place of b, and that's being squared there. Okay, so that could look like that. And then you could go clean this up one more step. So now the 2c minus 3d stays there. Right, this, if you wanted to, you could expand this to 4 times c squared. And then you could combine all this to make a 6cd. And then this could be 9d squared right here. Right. So you could do that. Right? And I think that would probably be about as factors you could take that. Right? Yeah, so that does factor like that. Right? Now, I know C and D are abstract ideas, kind of like X and Y or A and B. If you wanted to, you could always plug in numbers for C and D. Like, what if C is equal to pi and D is equal to 5 or, just whatever crazy numbers. Okay? And you can check and you can, that this first expression is equal to this factor expression at the end because they're the same thing. Right, so there's one pretty straightforward fundamental example. And another one I want to do with you guys is number 9. And this will be a factor by grouping type example. So here, I know it's pretty tiny on the camera. I'll write it bigger here. So number 9 goes a cubed x squared. So there's 6 different terms. So this is pretty long one. minus 16a cubed x plus 64a cubed minus b cubed x squared plus 16b cubed x minus 64b cubed. Okay, I think I got that right. Right. All right, so we've got 6 different terms. Yeah, now there is some way you can factor this, but it's going to be a process called, here, I'll spell this out. It's called factor by grouping, and I'll show you guys why. Because as soon as you see the pattern, oh, okay, actually, I kind of see what this kind of means by grouping. Right. Actually, you know what I should have done too is this fact here. This would be a difference of cubes, which is not too dissimilar from the sum of cubes, right? So sum of cubes and difference of cubes are right here. They tell you all these formulas on the first page of this lesson anyway, right? And so here, what do you mean by factor by grouping? Well, what I can do is I can group different terms together that have some things in common and then start factoring out and just kind of see where it leads. And sometimes the book will set it up in such a way that, leads to a certain outcome. You'll see what it's does. Like here, these first 3 terms all have one in common. What do they all have in common? Do they all have an a to the power of 3? Yeah, so it could factor that out. But it doesn't show up in these last 3 terms. So I can only factor out of the first 2 terms. So I'll do that and just kind of see where it goes. Okay. Also over here, all these 3 have a what in common?
Great.
How about a b to the power of 3? You guys see that too? Right, so I can pull that out. So I'm going to do a to the power of 3. And here I'll just do x squared minus 16x plus 64. Right? And over here, you know what? Maybe this too. Since 2 of my 3 terms are negative, this will help out anyway. You guys will see why. I'm just going to factor out not a b cubed, but a negative b cubed. Okay? And then what is left behind is a positive x squared. And then this sign actually changes to negative 16x. You like that? Okay? And then this would go back to plus 64, so like that. Right? Is that okay? Like this is equal to this, and this is equal to this. Do you guys see that? Okay. Like if you're ever not sure, you can always check your work by distributing back and working backwards, and it should match the original statement. So I think this is all correct. Okay. Now, do you guys see what is the next step? I have 2 giant terms right now. I have this term on the left and this term on the right. Do they have anything in common? Yes, everything in parentheses. So I can factor this out of both terms. Do you guys see that? So I can do that? So what I'll be left with is an a cubed minus a b cubed. And everything else is going to be, well, this right here. Because I just factored out. X squared minus 16x plus 64. Yeah, so now we're making some progress, right? And you know what? I think each of these in parentheses I can further factor. Because here I have a difference of cubes. I know what that is. That's what we just did a few minutes ago. That's this right here. In fact, you're looking at it. And so that's a minus b, and then a squared plus ab plus b squared. So that factors like that. And then this over here, can you guys think of 2 numbers that multiply to 64 and add to negative 16? What is it? What and what?
Negative 8 and negative 8.
Exactly. Yeah, negative 8 and negative 8. Right. Actually, you could call that x minus 8 quantity squared. You could do that too. Here, I'll write it that way, and then that'll be the last way I could simplify it. So a minus b, a squared plus ab plus b squared. This is all times x minus 8 quantity squared. Yeah, so that would be simplified form right there. There you go. So that's all right. Yeah.
Whenever it goes from a cubed minus b cubed, and then it switches to a minus b, and then it's parentheses.
Yeah.
It has 3 a's and 3 b's. Where do the first a and b come from? Because that's added. So
You're saying, how does this turn into this?
yes, because it said a minus b, so that leaves a squared and b squared, but it's 3 b's.
Let's try it out. So here, I'll write it bigger right here. So I'm making the claim that this is true. Let's see if that actually works. Is a cubed minus b cubed? So this is difference of cubes. Is that really? I'll say equals with a question mark on it because we're going to test this. A minus b, and then a squared plus ab plus b squared. This is the same thing. Okay. Well, I have to do sometimes what I call a superfoil, right? So it's like distribution. So this A distributes here, here, and here. This B distributes here, here, and here. So we're going to expand this out to 6 terms, then we'll clean it up. Right? And it should match this, but we're going to find out. A cubed minus B cubed. Is that equal to? Oh, that's fine. So this is A times A squared is A cubed. Then A times AB is A squared B. Then A times B squared is AB squared. Then negative B A squared. Then negative B AB, that's minus AB squared. And then negative B squared is minus B to the power 3. So that, okay, so that would be like that, right? Right. Now, what do I see? Ooh, I see A squared B here and a negative A squared B right here. So this and this cancel. And AB squared and then negative AB squared, those cancel. Oh, look what you're left with.
Oh,
A cube minus B cube. Yeah, right. Again, A, B are kind of abstract. If you want to plug in some numbers, like let's have let me try this. What if A is equal to 2 and B is equal to 5? I'm just thinking of something crazy. Right, let's try that. Okay. So actually well, let's go with that. Okay. So 2 cubed minus 5 cubed is that the same thing as 2 minus 5, 2 squared plus 2 5 plus 5 squared. Okay, let's see. So let's say 248 minus 125. Is that the same thing as, and then this would be negative 3. This would be 4 plus 10 plus 25. Right. So this should match this. Let's see if it does. Let's say minus 125 is negative 117. Is that the same thing as 4 and 10 and 25 is 39 times negative 3 is negative 117. Oh, yeah. Bing. It's the same thing.
okay.
Yeah. So check that. Yeah. So pretty good. Yeah. So that's a good investigation you guys can do there. Right. So things like that. Yeah. If you're not sure if something plays out, yeah, you can play around with it, work backwards and forwards, plug and make up some numbers. Yeah. Shortcut. All right. So you guys have time to I'll roll the full video in class where I solve a bunch of these ahead of time. You guys can watch that. You can work on Alex. Whatever is best use of your time here.